All right. So let's talk about our ECGs first. So I'm going to share my screen. Everyone can see this beautiful ECG right here. All right. So we're going to say that this ECG is going to be a 50 millimeter per second speed, right? And so if we say that that's 50 millimeters per second speed, what does that mean and how we count our ECG?
You need to count 10 boxes.
10 boxes. Okay. So we count 10 big boxes for 50 millimeters. 10 big boxes. Now, if it were a 25 millimeter per second.
5.
Okay. So everyone is up to speed on that. Get it? Speed. Okay.
No pun intended.
Yeah, exactly. I know. I live with a husband that does puns all the time, so that's why I have to do that. All right. So yeah, if it were 50 millimeters per second, it would be 10 big boxes. If it were 25 millimeters per second, it'd be 5 big boxes, right? Because every tiny, tiny box in the big box is 1 millimeter. Perfect. So everyone's on that. So in this case, we're going to count our big boxes. So this is 1 big box, 2, 3, 4, 5, 6, 7, 8, 9, 10. So on that one, we're just going to mark here. And we want to count as many as possible on a strip, right? So our next would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we mark here. And then we're going to have some leftovers. All right, everyone with me so far? Ooh, we have 4 people.
Yep.
Wait, it says I have 4 people waiting. Oh, God. All right. So we have 1 second here and 2 seconds here. Okay, so now what is our next step?
Count the number of R waves.
Divide by 6 seconds.
Okay, good. So yeah, you guys skipped 1 step, but yes, we're gonna count. We have to figure out a multiplication factor. So yes, so we need, right? We need 60 seconds, right? But we have 2 seconds, correct?
If you do 2 divided by 60, get your multiplication factor.
So you're gonna do 60 divided by 2. Because remember, like when you guys listen to a heart rate, right? On your own, you are saying, okay, you guys listen to how many seconds usually?
15 seconds.
15, right? So when you listen to 15 seconds, what is your multiplication factor?
4.
4.
4, right? So what you're doing is you're taking 60 divided by 15, right? And you're getting 4, right? So it's literally the same thing like we're doing on a piece of paper. Okay, so where did the 1 and 2 seconds come from? The 1 and 2 seconds came from us counting these boxes. So when we counted the big boxes, that equals this second right here. Does that make sense, Paige? So Michelle, you got 30. So it's, yes. So on here, we did 60 seconds divided by 2. You're right. is 30. So you're correct. Okay, so when we do this, we have 10 big boxes are going to equal 1 second. Does that make sense? So this on the top means 50 millimeters equals 1 second. And the 50 millimeters, so that means that 50 little boxes across equals 1 second. So rather than counting these little tiny boxes across, we're counting just 10 big boxes because it's a lot easier. So if we count 10 big boxes, that equals 1 second. Does that make sense? Okay.
Yes.
And then why do we count the first row when it's not a full row? We counted the first 10 boxes here, and then we counted the first and then the next 10 boxes here, but not these last 2 boxes. Does that make sense? Okay, wait, Melody, just wait.
Sorry.
All right, does that make sense on the first row bit? Hannah? Okay, okay. So if you're just counting, like obviously if it continued to go and there were 10 additional big boxes, we could continue to go, but we just stopped here. And so we're not going to count anything after this point. Just thought we had to start with none broken end. Oh, do you mean at this area right here?
So in the beginning, I would have had to start like skip the first 5 little boxes and then started to go full full. You know what I mean? It's like we don't count the first 5 boxes because I pause. We only count the full. And then
So you mean just in this beginning here, having 5 boxes in this little box right here? In this big box right here?
1 second. I can't see it first. So starts the legs, and then it goes out to the first step.
Sorry, it's just, I can't hear you.
Sorry, let me see if I can type it out.
Okay, sorry.
So basically you don't count, like when you count like your boxes, whatever that's left over, you just scratch out and you don't count if ever there's a P wave in there.
Correct. So yeah, so whatever's left over that you can't count, you're just going to not count any of that stuff that's left over. Correct.
Okay. And what about like, let's say at the beginning of your strip, let's say there's not like five little squares inside of your box. Do you like not count it at all because it's not a full square?
Correct, correct. So like if there were not 5 boxes here, you could start right here.
Okay.
Right? But in this case, there are 5 boxes right here. So I counted this box. It's just not, there's just not a line right here. That's all.
Okay.
So that's why I started there. Oh, okay. Okay. Now I see. Yeah. And that's why I was like, oh, should I count there? But if I started here, then I couldn't count this guy. So that's why I was like, oh, I'll just start there. Okay, perfect. So now what we do, so now that we have our multiplication factor, what we are going to do is, Molly said, count our R waves, right? So as long as we have a P wave, a QRS, and a T wave, we can count it. So if one of those things are missing, we can't count it. All right. So how many R waves do we have?
5.
5, right? Yay, everyone agrees. 5 R waves, right? And then we multiply that by our multiplication factor, which
That
is
is
30. Yay. And we get what?
150 beats per minute.
Right, 150 beats per minute. Always make sure you write what unit you have.
Beth, hey,
Yeah.
I think my computer froze a little bit right here. So when you were talking about like the beginning boxes,
Yeah.
if you do not have the full PQRS wave, do you have to go to the box that is like at the beginning of a full one, or do you still start at the beginning?
So, I mean, you can start wherever you want. I always try
Okay.
to start wherever there's a beginning, just to kind of squeeze them in. But,
Okay.
but yeah, you can start wherever you want. So yeah, our first step always is to count your boxes. And then second would be what?
Your multiplication factor.
Yeah, find multiplication. I'll just make a box. That way you know. Find multiplication factor. If you guys can read my writing. Find multiplication factor. And then our third step is what?
The R waves.
Count R waves, right? Your guys' favorite. Count R waves. And then fourth step is, yay, the last step.
Multiply by the factor.
Multiply R waves times multiplication factor to get beats per minute. Hopefully that makes a little bit more sense.
Can we do another?
Yeah, absolutely.
Beth, I have a question.
Yeah.
So you said that like for your QRS, you have to have like a full, like the correct outline, I guess. But I've noticed like in the quiz, there's somewhere like your R is like downwards. Does that not count as a R?
So it does count as an R wave. So that gets a little tricky. So that's a great question. So you'll notice that a lot, especially in cats, which can be normal. It depends too on, sorry, I'm just trying to find an ECG really fast. It depends a lot on like whether you're looking at like VPCs, stuff like that, which are always fun, as you guys know. So you do still count those regardless. So yeah, it gets interesting. Okay, these are kind of hard to read, but I think we can do it. Well, these are kind of, this is kind of a fun little, I like this little thing. Okay, well, we'll do this because you can see the big boxes, but it's hard to read the little boxes, but who cares? You guys don't need to see the little boxes. Okay, let me put this in my, if you ever get any ECG books too, there's this one really good ECG book. It's super old for technicians, but it's really good too. I can find it and put it on our Facebook page for you guys, but it's really good, like kind of a beginner ECG book that explains ECGs really well. I think it was published in like 2009 or something crazy, but it's good, and it's like spiral bound, which I like. But it's good for when you obviously are graduated and trying to like learn more about ECGs. So I recommend it. If you're interested more in ECGs. Some people are like, nope, I'm good. Number 5 you struggled with. Ventricular premature contraction. Okay.
Oh, because I asked what a VPC was. I wasn't sure.
Got it. Yeah, I can show you what that looks like too. So
that's something where I'm still not sure of like identifying like what's what.
Yeah.
And one of my questions actually for that is, you know how you said that like in surgery you want to be able to look like at a monitor and kind of have an idea of like what's going on, like you can do your BPM with that. On a monitor, are there like actual boxes that you can count? Like how do you know what the speed?
So on a monitor, obviously they're gonna tell you exactly what that looks like, but so they're not boxes. But if you do a printout, it will actually have the boxes and stuff for you to be able to count out. Usually if you are working, stop barking. If you work in like cardiology and stuff like that, they will be able to have additional things for you to be able to do, like reading, you know, all different types of things and changing like speeds and all of that. Oh, this is like such a good little thing I found. I love it. So yeah, you'll be able to do that kind of stuff. So let me find you guys one that's a VPC on here so that I can show you kind of the difference. Oh, it's gonna make me spell out. So there's a huge difference in what a VPC looks like compared to just having like your QRS complex just be below the axis. And so a lot of times, especially in cats, you'll notice that theirs will fall below the axis, and you know, people will be like, oh my gosh, you know, they are having VPCs, and that's not the case. And so the difference with that is that here you'll notice that you have a P, QRS, and T, right? All of these have your P, QRS, and T waves. And then all of a sudden, you have this P, QRS, and T. And then this guy right here, this doesn't have a P wave, right? Does anyone see a P wave here?
We can't see where you're pointing.
Oh, you don't see my mouse?
No.
Oh no, okay. You guys used to be able to see my mouse. That's not fair. Okay, so does anyone see a P wave right here?
No.
No.
Oh, okay, so no P wave. And so all of a sudden, the ventricle, right? So this is your QRS right here, right? The ventricle goes, nope, I'm cutting the atrium in line, and shoots out its QRS. So that's where it goes ventricular premature. It prematurely cuts in line. And so that's what it looks like. So when you see what it says, wide and bizarre, so wide and bizarre, right? That's what a VPC looks like. So when you see these kind of things, That's a VPC. And so sometimes you'll see runs of these where they kind of look like this, right? That's ventricular. Well, if it's greater than 180 beats per minute, that's ventricular tachycardia. That's like really bad, really, really bad, right? And then the next form that we'll see after that, if we don't fix that, ventricular tachycardia, you'll start seeing VFib, right? Ventricular fibrillation, which, do you guys know what ventricular fibrillation looks like?
Nope.
No? Oh, you guys want to see my drawings?
Yeah.
Ventricular fibrillation just looks like this. So you guys have probably seen this on, you know, well, you guys old people probably ER, right? Or like Grey's Anatomy, or I'm gonna go through all the generations here. Grey's Anatomy, or what other shows? Chicago Med, what else? What other medical shows? Right?
Good doctor.
Good Doctor. Oh my gosh, you guys watch that show? Okay, Good Doctor. So yeah, that is your ventricular fibrillation. So this would be like coarse, and then they have fine, right? It's really fine. So this is when we use our defibrillator, right? We want to use our defibrillator because if we don't do something at this point, our animal's dying, right? And so after this, what's our next step?
Give your emergency meds.
Well, sure. But what happens to the heart if we're not doing anything at this point?
Cardiac arrest.
Yeah, so we hit, what's this?
Flatline.
Flatline.
Flatline or asystole, right? So it goes through this like crazy course of things, like my heart's really sick, right? So we have plenty of time to intervene. So many times it's like our animals usually don't just die on us, and the heart doesn't just stop. There's a process that it goes through. Now, it could be fairly quickly. It doesn't mean that it's like, oh, this took hours to go through, but we can monitor it and see that it is going through these steps, you know, of that. So ECGs can tell us quite a bit. Now, you know, having one VPC doesn't mean that we're going to go through all these steps and our patient's going to die. You know, we have VPCs and that could be normal. But if we start having more and more, then it's something that we need to definitely address. You know, that the heart just doesn't stop. It's still a super big fear of mine while monitoring. Yeah, definitely. And
And
so
when something's wrong with the P wave, that's ventricular.
So when something's wrong, so with the P wave, right? P waves mean atrial,
Oh,
right? It's okay. QRS equals ventricular. Okay. So that kind of narrows it down for you guys for when you are looking at, okay, what type of issues am I having with my animals, right? So yes, you can look at, okay, my P wave, this is how the heart functions. You know, my P wave is going through, you know, atrial depolarization, and then in the QRS, it's going through atrial repolarization and ventricular depolarization, and the T wave is going through, you know, ventricular repolarization. But to try to remember what kind of, you know, thing that your ECG is, right? Just remember, if there's something fishy with your P wave, it means there's an atrial issue. If there's something wrong with your QRS, it's a ventricular issue. So if you have, you know, this, and then a nice QRS, and then this again, and a nice QRS,
Your ventricular.
Atrial.
it's an atrial issue, right? Because your QRS is beautiful. Well, this one I just drew horribly, but that's just me. But this looks very similar. This looks very similar to this, right? And this is ventricular, ventricular
Isn't that atrial?
fibrillation, right? That's ventricular fibrillation. And this is atrial. So this would be atrial. And if it looks very similar to this and this look very similar, and it's just opposite, what would this be?
I can't see your arrow. I don't know what you're pointing at.
I know. What would this be?
Oh, okay.
Atrial fibrillation.
Atrial fibrillation. Good. Now, what would this be?
Ventricular.
Ventricular or atrial tachycardia.
I'm like trying to.
The repolarization and depolarization, it just confused me. I just keep mixing them up.
Yeah, don't worry about those. Just remember these guys.
Because I know, like, I had some questions in it's kind of like the vet tech prep thing, but like in French, it's the ATSAC book, and like there's questions where they talk about like repolarization, depolarization, and I just got so confused. I didn't know what was what for those ones.
So Amanda, you said atrial fib. So atrial fib is this one right here. So these two get confused all the time. These two get confused all the time.
Is it ventricular tachycardia?
Nope. No. So is it atrial? Let's start there. Is it atrial or ventricular?
Oh, duh. It's
Atrial.
atrial.
Atrial, okay. And then what else could it be? This is a sawtooth. Let's start there.
Fibrillation.
That fibrillation. Remember, this one's fibrillation. It starts with an F. Flutter, yeah. Remember, flutter is not a pretty thing. Flutter is in the cardiac world is a really dark and gloomy and horrifying sawtooth. I try to tell people that, like, just remember, it's not pretty. It sounds pretty, but it's tricky. So, because we think, oh, atrial fibrillation, oh, flutter. Yeah, that would be flutter is this, right? Because it's fluttering through. No, this is fibrillation because it looks just like, ventricular fibrillation. But flutter is the sawtooth. It's the horror story of cardio. So those basic, those basic ones for you guys to kind of know and kind of at least be aware of are good for just going into practice and kind of knowing or being aware of is really good. Doesn't mean that you have to know how to recognize them every single time or anything on that level, but being aware of them is really, really good. And And like I said, having a really good book or having, you know, these things drawn out so that you can kind of refer back to is really great. So yeah, I mean, don't put that much pressure on yourselves. Really don't. Everyone is still learning.
Aren't there shockable and non-shockable
Yes.
rhythms?
Yes, absolutely. So the big, really shockable ones that you have, remember, are your fibrillation ones. So atrial fib and ventricular fibrillations are your big ones that you can shock. Obviously, asystole you can try to shock, but it is hard to do. And then, of course, you're going to have your drugs, and you have to do CPR on top of that.
So you said fibrillation, and what was the other one?
Well, your fibrillations one. So ventricular fibrillation, atrial fibrillation, and your asystole. And then remember your drugs that you, obviously your main drugs that you want to do. So, you know, we can get into obviously your main drugs to start. So you're going to start like your epi, so your epinephrine is the first drug that you're going to want to give, right? That's the one that's going to help like get that adrenaline going to start the heart, right? Atropine is to maintain the heart rate. So those are our big drugs that we want to give first. And then from there, we can give additional drugs as well. So and then knowing your drugs that you can give down your endotracheal tube as well. So you guys know those. I know we've gone over those. So your naval drugs, right? You guys know your
Naloxone
naval.
and
Naloxone, atropine.
So naval.
epinephrine, lidocaine.
Yep. And epinephrine.
Good. Oh gosh, I'm like highlighting everything. Stop it. Yeah,
So
so
one is naloxone.
naloxone, atropine. Good. What'd you say for a V? Vaso.
Vasopressin.
Good.
What is that one? Never heard that one.
Epinephrine and lidocaine. Awesome. All right. So you asked what vasopressin is. What's vasopressin?
I think of vasoconstriction or vasodilation.
Good. That's good. So why would we want a vasoconstrictor?
To conserve energy or blood or something.
Okay, good. Blood. Conserves blood. Think of when a patient is dying, right? They lose that blood pressure, correct? That's all kind of relaxing out or whatnot, right? Where they're just relaxing out. And so their blood pressure tanks. So we need to bring that blood pressure up somehow, right? So if we give a vasopressin to constrict those vessels, it's going to push that blood supply back up, right? And bring that blood supply, especially back to the heart and brain and all of that, at least temporarily, to conserve and help that body as much as possible until we can stabilize them, correct?
Mm-hmm.
So that's our point of at least the vasopressin. Does that make sense?
Yeah.
Awesome.
And then lidocaine, that's like a local anesthetic.
Yeah.
Well, you use lidocaine in that situation.
Yeah. So good question. Why would we use lidocaine? What's the point of lidocaine during?
To slow down during like the tachycardia.
Good. So how does that work? How does that work for the heart? Any thoughts on that?
Would it
Magic?
be like the opposite of a vasopressin? So it like increases or decreases the blood pressure?
It potentially could, yeah. But what does it do to the heart? What is the heart?
It's a pump.
It's a muscle.
It's a muscle, right?
It relaxes the muscle?
Yeah. It tells the muscle, you need to chill out.
Sorry.
That's right. You're right. So it says, you need to chill out, heart. You need to chill out. You're freaking out too much.
I always
Maybe
thought,
you
like,
guys need a little lidocaine too before you're like, it's VTNE. A little lidocaine all over your body, right? Yeah, so it relaxes it temporarily and it's like, okay, settle down. Yeah,
always-
before the test, just, ugh.
I always thought like
Yeah.
lidocaine, like I always thought of lidocaine like paralyzation, like you can't feel it, like numbness. So I was confused when I'm like, what?
Yeah, it just does, it relaxes it just a little bit to be like, all right, relax, kind of like restart what you're supposed to do, right? Because you're just having a little freak out session, right?
Mhm. So you would give like all like the naval drugs, like you can give them all in at the same time, one after the other.
Yep.
Is that you? Wow.
Yeah. Whatever you need to give, right?
Okay. You don't have to use all of them, but if you need to use all
Correct.
of them, you can.
Yes.
Okay.
Yes.
Interesting.
So these can go down the endotracheal tube if you need to. And then if you put them down the endotracheal tube, what do you do to the dose?
Double it.
You double
Double
it,
it.
right? Yeah. Absolutely. Good job. That's awesome. Okay. Do you want to go back to our other ECG now that we went on a tangent? And do this guy?
Why would be double the dose? Sorry, I'm continuing tendon. Just trying to figure it out.
That's a good question. So because we're not giving it IV, right? So the IV dose is just a smaller dose compared to giving it like a well, I guess I wouldn't say transmucosal, but giving it as a dose that has to be absorbed, I guess. So that's the only reason why. Yes, I can make the ECG bigger, of course. So yeah, it's just a different dose. Same thing with if you're giving it, so you can give these doses, say intracardiac. So if you're giving the doses intracardiac, you give the doses, technically you would give them 1/10 of the dose. So that's because you're just giving it straight, into the heart. But I've seen doctors, of course, when you're giving it straight into the heart, it's kind of one of those last resort type of things.
Mhm.
So, some doctors have given, them different doses each time, because they're like, okay, we just need to try whatever we can. So, but technically the dose is 1/10 of your normal IV dose. So,
And I'm wondering if you give those in the ET tube, wouldn't you worry about aspiration pneumonia?
nope. So that's also a good question. Not necessarily, because they just actually get absorbed through the, through the respiratory system. So as you know, the respiratory system isn't totally a dry system. So there is some moisture that's in there. So there are some people that even dilute it down, which makes me a little nervous with them putting obviously sterile saline down there. So it actually, they don't get necessarily aspiration pneumonia. Plus, even if they did get aspiration pneumonia, our goal is to get that patient, they're essentially dead, right, at that moment.
Mhm.
So we would rather them come back and then deal with aspiration pneumonia when they are alive, right? So we'll take that chance. So
Interesting.
yeah.
All right.
Yes.
Patient-
Yeah, I know it sounds crazy, right? Like, all right, well, we'll just deal with the aftermath when we get them back and stable again. So yeah.
Cool.
All right. Okay. So let's do this. can you see this ECG a little bit better? Yes. Let's make this one 25 millimeters per second. And let's have you guys do this one by yourself. Does that sound good? All right. Oh, you guys are so fast.
I don't count that one.
All right. Ooh, you got it, Paige. Good. Awesome. Any questions? Dana, you got 150. So
Okay.
do you have questions on that one? How'd you get 150? Did you do it with 10 boxes or 5 boxes per second?
1, 2, 3.
All right. Everybody counted off. Okay. Awesome. Everyone good on this? So we got 6 seconds because we counted 5 boxes each, and then we got the 6 seconds. So our multiplication factor was 10 here. So 60 divided by 6 was 10. And then we got, you just gotta, yeah, remember each step, right? And then we got our R waves there. So all of those guys. So 8 R waves times 10 equals 80. So yeah, if you try to just remember, like, how do I do my heart rate when I listen to an animal, right? It's literally the same thing. Except for you have to count these boxes. So as long as you can count these boxes, you're good. All right. Oh, you guys got it. Good job. It's just practice, 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 practice. Okay. So we got that one down. Anything else? Any questions on some math that you got? Any questions from this week? Ongoing losses I saw.
How about ongoing losses and oxygen,
Okay, yeah.
please?
Like the oxygen, which oxygen one? The oxygen with the H tank, E tank one, or oxygen where we have to do oxygen flow rate?
The flow rate.
Okay,
I think with the tank, it just depends on which one.
right.
And you divide the H tank is the big one and it holds 6,600.
Yep.
And the little tank is your emergency tank and that's 600.
Yes, 660 liters. Yep.
660 liters. And then you, all right, yeah, maybe if we could go over that.
No problem. No problem. Totally. Flow rate. Okay, perfect.
Beth,
Yeah.
the ongoing losses on that math quiz, I just can't get it.
Okay,
When you
yeah, let's do
like
that.
when you were factoring in like the vomiting, diarrhea into the fluid rate and all that.
Yeah,
No
no,
matter
let's
what I
do
do,
that.
I just can't get it right.
Okay, yeah, no problem. All right, so let's say we have a 45-pound dog. Okay, and this dog is 7% dehydrated. Make it weird. All right. And the dog vomited 3 times 2 tablespoons and had diarrhea 2 times 1 ounce each, right? The doctor wants to, so DVM wants to correct over the next 16 hours. All right. So the first thing we want to do is we want to figure out so we want to do 3 things first. So we want to figure out our dehydration. We'll want to figure out our ongoing losses, and then we're going to figure out our maintenance, but adjust the maintenance for the 16 hours, okay? And then after that, we're going to figure out all of them together and then figure out the hourly rate, okay? So let's do our dehydration first, okay? That's like our easy one. So how much does our patient weigh in kilograms?
20.4.
Perfect. So 20.4 kilograms. And so how do we do our dehydration then?
And kilograms times 7 as a decimal
Good. And then
times 1,000.
Perfect. And we get what?
1428.
Beautiful. So 1428 mLs. And then, so that is what our first answer is. And we'll save that answer for the end there. So for our ongoing losses, so this is everyone's favorite part, is that we're going to figure out our ongoing losses first is going to be easiest to do this, is do vomiting first. And it's going to be, all right, 3. So he vomited 3 times and it was 2 tablespoons. So 2. And then how much is a tablespoon?
15 mils.
15.
Perfect. So 2 times 15 is 30. And then so 30 then times 3 is 9. How much?
90.
90. Good. Like, I don't want to give you the answer. Okay. So vomiting wise, he vomited 90 mils. So then let's figure out diarrhea. And so if he vomited diarrhea, he did 2, vomited 2 times, and then it was 1 ounce. So that's easy, luckily. So that would be how much?
60.
60.
60 mLs. So let's put that together. So 90 mLs plus 60 mLs equals
150.
150 mLs. So that's our ongoing losses that he had. So we'll, at the end, add these 2 together, and now we just have to figure out our maintenance. So for our maintenance, we're going to figure out, we're going to do a little backtracking. So we'll do our maintenance all the way to hourly rate and then multiply by 16 to get how much we need for 16 hours, if that makes sense. So how do we figure out maintenance?
Is it 5
This-
mils per kg for a dog?
So that would be maintenance for surgery.
Okay.
60 ml.
Good. So 20.4 kilograms times 60 mLs is how much?
1224.
1224 mLs. All right, so that's per day. So that's good. So how do we do, so now let's do it per hour.
Divide by 24.
Good. And we get what?
51.
51 mLs. Awesome, per hour. So now we need to figure out, remember, 16 hours. So we'll multiply that by 16. And we get how much for 16 hours worth?
860.
Great. Okay, so now we have all 3 of our numbers that we're going to give this guy for fluids for 16 hours, right? So we're going to add those 3 together and then
It's
figure out our rate.
816.
Oh, sorry, 816. Oh, I was gonna over give him fluids. Okay, so 1428 mLs plus 150 mLs plus 816 mLs. All right, so now we can add those guys together.
$23.94.
Ooh, 2394 mLs. All right, so that's per 16 hours. All right, so now we have that. So how much for 16 hours? So now we have to figure out an hourly rate for him. So now we should be in the home stretch, right? So how do we get an hourly rate?
Do you divide by 60? No.
Yeah, let's do an hourly rate. So divide by,
Your 16 hours.
correct, good. So divide by 16, good. And what do you get?
149.6.
Oh, fuck.
149.6 mLs per
Ow.
hour. Awesome. So that's our hourly rate for this guy. All right. So now let's go to 149.6 mLs. So this means dehydration, the D. The O stands for ongoing losses, and the M stands for maintenance.
You're a mess.
I know. I'm sorry.
I'm a mess. I said divide by 60. I don't know what I was thinking.
I say I'm a mess all the time, but it's all right. You know, like it's hard getting old. Oh, that was perfect. So how do you move on from that? Okay, so you take 149.6 mLs. So how do we figure out our drip rate?
Fuck the drip rate.
Oh God.
Nope.
And
The
Sorry.
drip rate.
Oh my God, I'm so sorry.
I love it. I
Is
know.
the 3600 on the bottom?
Yeah.
Stop that.
All right, perfect. And I know everyone loves this drip rate. Everyone loves it. And then what is our macro micro set? I know I mean, the drip rates, you know, we all love them.
A macro is 15.
Great. And you guys want to do macro, yeah?
Yeah.
Yeah.
Awesome. We concur. 15 over ml here. So we're good. So awesome. Now we can figure this guy out. So what do we get? Hopefully something easy, right?
0.62.
Okay, 0.62 drips per second.
Beth, question.
Yeah.
For your DOM, I got 14.9, and then you wrote 149.6. Is that, what did I do wrong?
Got 14.9. Somewhere in the decimal, I would guess.
So I did 2394 divided by 16.
Try dividing that again, the 2394 divided by 16. I think you might have added a 0 in the 16.
Oh, you're right.
Okay.
Thank you.
Now, was this the part where we gotta find a whole number to multiply by to get?
Yeah.
This is the part where
Oh.
I failed miserably.
You did, Amanda, you did 13 drops per 3 per 5 seconds. That's a fun.
Oh, I just got it. 5 for 8 seconds.
This is just one of those things where we're just playing games here. So let's see. Recheck your answers. So let's see. 13 drops per 8 seconds. So take 13 divided by 8 again. Nope. That wouldn't work. Because you could, that would be 1.625. 3 per 5 is close. That would be, I would accept that because that would be 0.6, right? So that's pretty close, right? But I'm closer, so we're playing a game. 1 drop per 8 seconds. So 1 divided by 8 would be 0.125. So you're on the right track because you had the 8 seconds, but not quite there yet. 3.5 I talked about. 6 drops per 10 seconds. You're correct in that by multiplying by 10 seconds. So good job, Melanie. And then 3 drops. Your drops are wrong. Remember GTT. I've done that before too. Per 5 seconds, you're good. By Sydney, thank you. And then 1 drop per 2 seconds. Nope. That's too far away. You change your entire fluid rate actually. So that's not close enough. I got too excited and finding a whole number. Yay!
How did
Awesome.
you get the 8 again?
How did I get the 8?
Yeah.
I play with numbers.
So basically the important part is that we have our 0.62 drops
Yeah.
per second.
Yeah, so in the end, you want to be as close as you can to that 0.62. So you either know like fractions and decimals really well. So, I mean, I know like a decent amount, but sometimes I'm like roughly around that. So I just take 0.62 and I go, okay, if I multiply that by 7, am I close to a whole number in the end? Nope, I'm not close enough by multiplying by 7. What if I multiply by 8 and I was at like 4.9 and change? And so I'm like, okay, that's pretty close. So then I said, okay, 5 divided by 8 was 0.625. So I'm like, yep, that sounds good. So
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 you just want a
basically-
whole number. It doesn't necessarily have to be like 1.
correct,
Okay.
correct, yeah.
Okay,
just a
that's my
whole number.
problem.
Yeah.
This whole time I'm like, I need 1.
No,
but
no,
I just
no,
need
no.
a whole number.
You need
Okay.
a whole number.
Oh Lord. Okay, that'll
Yeah.
be easier for me now.
Yeah. Bye, Alexis. Thank you. Have a great Easter. Don't eat too much candy.
So let's say if I did like times, what did I do, 6?
Uh-huh.
And I got like can you round it up afterwards?
So as long as it's fairly close, like mine was like 4.9 and some change, that's totally fine. Because as long as you're really, really close to that initial number right here, that's totally fine. As long as you're really, really close. If it's like, ends up being 4.4, no, don't round that, or 4.5, not close enough. But if it's like 4.9, yes. Or if it's 3.9 or whatever, you can round it because you're close. You're not going to always get an actual whole number. I mean, it'd be nice, but yeah.
So let's say it's like 5.58. I can't round that up to just say, yeah, I'll put
Nope. Yeah, because you want it to be as close to this, in the end, you want your drip rate to be super close because you don't want to, like I was saying, the 1 drip per 2 seconds is only 1.5, right? That's going to change ultimately your actual fluid rate quite a bit, where you're not going to actually, it's under the fluid rate. So it's going to ultimately change it too much and your patient's not going to get the total number of fluids that it actually needs. So that's why I have to try to keep it as close as possible. So Granted, we changed it just a smidgen, but that's not going to change your ultimate fluid rate that much. It might change it by like a mil or two. So that's not that big of a deal. So, but I'm glad we cleared that up. Good job.
So I have like 1.86. I just like round it up to 2.
Yeah, that's fine.
Okay.
Yeah. Awesome. Okay, so now we can move on to, let me get to the bottom because it's easier, I think. I don't know. Or not. Just stick it somewhere. Okay. So now we can move on to, any questions on that one? We're good for now? Let's do our I guess our H tank and E tank. So our H tank, right? H tank and E tank. So we are saying how the H tank always has a pressure of 2,200 psi. And so does our E tank, right? So they always have the same pressure in there when they're filled completely, right? But since the H tank is so much bigger, the actual amount of liters that's in there is 6,600 liters. And the E tank, since it's smaller, has 660 liters in there, right? So when we're figuring out how much is left in our tanks, we do have a constant that we use to figure out the liters that are left. So what we use in the H tank, the constant is 3. And the constant that is in there for the E tank is 0.3. And so the method behind on how they figured that out was based on these numbers. Okay, so if you care to know why, that is the reason why. You guys don't need to know that, but that is the reason why. So when we are figuring that out, and when you look at your tank every morning, hopefully every morning that you look at it, you'll look at the manometer and it'll say on there, hey, you turn it on and it'll give you on the manometer like you have currently, 1,584 liters left. And so then you'll have to figure out how much time you have left in your tank. So let's figure out how much we have left in our tank. So today, when you look at your tank, you have 1,548 liters. I think that's what I said. I don't know. And you are using an H tank. So we have an H tank. You will be running your oxygen on your patients at roughly 1.2 liters per minute. How many minutes will you have left? How many minutes? Exactly. Who's that one? Right. All right. So how do we figure that out? What should we do?
Do we have to multiply by the 3 first?
Exactly. So we'll multiply this guy by 3. And so we'll find out how many liters. Oh, I lied. This should be PSI. I'm like, wait, this is PSI. I'm like, wait, this is wrong. So the 3 comes from, so the 3 is a constant. So it comes from when we take this 6,600 liters and it is divided by the 2,200 PSI. So we get this constant. Same thing with this. So I should actually, so that you can see the representation of it. The 660 liters. Does that make sense? So when you see it in the morning, it'll say you have 1,548 PSI. Now we have to find out how many liters. So we multiply that by the 3, which is the constant. And if it were an E tank, it'd be 0.3. Does that make sense, Paige? Maybe. So yes, we multiply by 3 to get how many liters we actually have in our tank. So how many liters do we have?
4,644.
1,644 liters. Awesome.
4,600.
Oh, 4,644. Okay. Thank you. Okay, so now we figure out how many minutes we are going to have left. So for you linear people, I'll try 4,644 liters. Okay, and so we are running our patients at 1.2 liters per minute, right? So we're going to take that and go 1.2 liters per minute. I lie. I can't do this linear stuff. So we're going to actually take this for you guys who do linear and put it like that, right? So we're essentially dividing that by our liters per minute. Okay, for you other people who kind of do math like me, we essentially just divide out our liters per minute. So we say, okay, if we're going to do our if we're going to have our patients run at 1.2 liters per minute for the day, we just divide 4,644 liters. We just divide that by 1.2 liters per minute, and it leaves us with the rest of the minutes, correct? So we are just left with minutes. So what do we get? Yeah, go ahead.
Oh, sorry. I'm just trying to figure out where we're going with this. So the 1548 PSI, is that the amount that you have left in your tank?
Correct. Correct.
And
So when
then-
you turn on your tank in the morning and you look at your manometer, it'll say 1548 PSI. And
Okay.
so from there, that's when you go, okay, I need to multiply that by the constant, whatever that is. That gives us our liters. And
Okay.
from there, we're going to say, okay, what am I going to run my patients through the day, like average that out? And then we'll say, all right, is it 1.2 liters per minute? And then you take that, divide that by the 1.2 liters, and it leaves us with our minutes of how much we have left for minutes.
Okay.
Okay. So how many minutes currently are we going to have left? Somebody has 3,870. Okay. Minutes. So I think we'll have enough for the day. Amanda said 64.5 hours. If we go to hours. So by just dividing by 60, if you want to do hours. Does that make sense to everybody?
Yes.
Okay. Awesome. So say we have a 25-pound patient for surgery, and we'll just give a body condition score too, because why not? Let's see, 5 out of 9. And we need to figure out their oxygen flow rate and bag size. So we need to do O2 flow and bag size. So let's go ahead and do that. So Yeah. So let's start with oxygen flow. How much does this patient weigh?
$11.4 kilograms.
Yeah, 11.4 kilograms. So are we going to do rebreathing or non-rebreathing?
Rebreathing.
Free breathing.
Okay,
Over 7 kilograms.
great. So what is our, what's our formula for rebreathing?
Is it 20 to 40?
Good, 20 to 40 mils per kg, good. So we'll have 11.4 kilograms, right? And then we'll do our 20 to 40 mils. So what do we get for 11.4 times 20?
And then 456.
And then 4. Awesome. So how many mils of O2 are we going to run for this patient at least?
228.
It's a trick question a little bit.
Why would you use one versus the other?
So remember, we are always going to run at least when we are inducing, right, the higher rate, and giving them more O2, right?
Right.
And then especially if they're doing well, we can always back them down to the other. Also know that when we run them at the higher rate, we also are going to be giving them more anesthetic too. So you have to adjust that as well. And then do they really need all of that oxygen? You know, so kind of playing with that, like, are they doing well with the lower amount of oxygen? So we always will start them at the higher one, but you can do a lower one if they're doing fine on it. So usually we do the higher one at induction and recovery, and then the lower one as long as they're doing fine throughout the procedure. Now, so induction at 4.5 liters and maintenance at 2.5 liters, that's a lot for a little dog. So that, I wouldn't say that. So, this is for mils, remember. So we're not in liters yet. So remember we have to have a minimum of what? How many liters? How many milliliters of oxygen?
0.5.
Exactly. So we're not even there yet, right?
Yeah.
Right. So our minimum that we have to give for this patient, no matter what, is 0.5 liters. So in this case, this patient hasn't even reached that yet. So now we are like, oh, okay, we're under that. So this is going to happen a lot with our little patients, is that no matter how much that we have calculated out, they reached under 0.5. So we just have to like cross it out and go, okay, we didn't even reach it. So we're still going to run our patient at 0.5 no matter what. So that's our answer. Okay. Makes sense? Hannah, I was like, what are you doing? 4.5 liters and 2.5. And then I realized what you did. I was like, oh, never mind. Great. Okay, so then now we need to do bag size. So for bag size, how do we figure out bag size?
Times 6.
What times 6?
The tidal volume.
Tidal
The
volume.
tidal volume. I'm like, I know what you are saying. I can read your brain, but see, I feel like I could do your VTNE if I just read your brain. Like, let me just give it to you.
Can we arrange that? That would be awesome.
Exactly. I'll just read your brain because I could do that for you, and we'd be great. Okay, so tidal volume times 6. Perfect. So how do we do tidal volume? What is that?
10 to 20.
Perfect. 10 to 20. And then what do you do with your 10 to 20?
Or 10
Multiply
to
by
Multiply by kilograms.
Good. Kilograms. Great. So see, I'll do it again. 11.4 kilograms times your 10 to 20. Good. All right. Awesome. So what do we get here?
114.
Question. Could you just use your 0.5 for your tidal volume? Instead of like your 10 to 20, like could you do like your 11.4 times 0.5?
11.4 times 0.5. I don't know. I don't know what that means, I guess.
Like for, because like for your flow bag, we have the 0.5, which would be like your minimum.
Oh, I'm sorry, this should be per minute. I forgot that. But these are two separate problems, I should say.
Okay, never mind.
Yeah, I know everyone gets confused on that. These are two separate problems, yeah. Because remember, this goes to the flow meter, right? Flow meter.
Mhm.
And then this is for your bag.
Gotcha.
Yeah. That's a good question though. A lot of people get confused on that. Okay. So 114 and then here we have 228. I'm going with
Yes.
if I can do math today. Awesome. And then here we multiply by 6 and here we multiply by 6 as well. So what do we have?
So 684 on the top. And 1368 on the bottom.
Ooh. These are interesting ones. Okay, so then we'll divide those by 1,000 to get our liters, right? So we have 0.7 liters. I'll just round. And then this will be 1.4 liters. So now we have to try to figure out a bag for those, right? Ugh. So obviously we don't want to go down in a bag, right? Go down in a bag size because that'll make things smaller. We don't. So what bag would you guys prefer to choose for this patient? A 1 liter bag? Awesome. Anyone have a better suggestion?
1.5.
We could go to 1.5. It might be too big because again, we haven't reached that 1.5 quite yet, but we could do 1.5. It's not a bad idea by any means. I think the 1 or the half liter is the bad idea for sure, but you could do 1 or 1.5. 1 liter would be the most ideal. If you don't have a 1 liter bag for some reason, 1.5 would be fine too. So awesome. Great. Any questions on those two? All righty. Any other questions when it comes to that? surgery fluid rates. Remember, we have our dog is 5 milliliters per kilogram per hour. And then cats are
3.
3. Good. What is a shock?
For dogs.
90 for dogs.
90 for dogs.
And then
Good.
45 for cats.
55 for cats.
50 to 55 for cats, roughly, somewhere around there, right? And the funny thing, right, is that that's roughly the blood volume of cats and dogs. So you're placing their blood volume, which we'll get to when we finally get to emergency. I can't wait. But this, we're getting
I'm
there.
so excited about emergency.
Me too.
I know, me too. I love it. I love it. It's my favorite. We'll have so much fun. Awesome. Any other questions?
Do we have some fun parasitology quizzes that we can go over?
I don't have anything today for you for that, but I could get stuff for you if you like.
Yeah, that'd be awesome. For
Okay.
sure, is that I wasn't exactly sure what they were. I forgot to write a note about them, which is not very useful for today.
Okay.
But yeah.
Yeah, I can get some parasitology stuff for you guys.
Can we do another Sunday study session with that game?
Yeah, no, absolutely. I'm planning on doing that for you guys a lot more. So
'Cause I missed
yeah.
that one and it looked really fun.
Yeah.
Oh yeah, no, I'm planning on doing a lot more for you guys on that. I was gonna do that for today, but then you guys definitely needed some of the ECG stuff and that kind of stuff. So I knew that we wouldn't have time for that today. So, but no, I loved it. I love doing that. It was fun. Yeah, that game gets me hyped. Yeah,
I missed the game. I'm so sad.
yeah, we'll do that a lot more. Don't worry.
This is a hard time. I work Saturday night 6p to 6a, then I got to go back in tonight at 6p.
Oh,
So this is a tough hour
Yeah.
for me to make.
yeah, no, we'll do that a lot more, definitely. So it's hard to do with math, especially if I try to do it with an ECG, I don't think you guys would die. So, but no, we'll do that a lot more, especially with the weeks coming up, because there won't be as much like math and that kind of stuff. So, and it'll be a lot helpful as you guys prepare for the VTNE aspects of things with questions and all of that. So yeah, no, it was a lot of fun. I enjoyed it and stuff too. So
Is there a way that we can do that, like on the Facebook group? Like, is there?
so there's a lot of different things. I know there's a way that I can even set it up so that you guys can even do it alone, like separate, like on your own time. So I just have to figure it out. So, which might be kind of fun, but I might be able to do it some way, like as a link too, for you guys to do it, like as you said on the Facebook group. So,
Awesome.
but yeah, no, it was a lot of fun. I like it. So
Do you
Beth, I
have-
do have another question. Sorry.
yeah,
Who I interrupted.
Yeah.
I don't know if you'll know this, but I was like reading through the book over this chapter, and there was like the MCV, the MCHC. Are there a lot of those math on the VTNE?
not horribly. You know,
Okay.
there might be a couple here and there of just, you know, kind of like microcytic, macrocytic, like that kind of stuff, but nothing
Okay.
too crazy of, you know, what in all
So
detail, I guess.
It's just good to know them, but
Yeah.
it's just okay.
Yeah. You know, it's nothing where you guys have to be experts in each domain, each field, that kind of thing, but it's good to have an overall view of what it's all about, you know. Like knowing, you know, how to, you know, do a platelet count, knowing how to like all of your leukocytes and what they do, and that kind of stuff, or knowing your red blood cells and like polychromasia and what that means, like stuff like that. So yeah, I have notes for that. I can share that with you. Oh gosh, you're gonna make me dig for all of that stuff. So yeah. So yeah, I mean, I can share as much as I can with you guys on that kind of stuff. And those videos are really good. So, you know, I shared all of those videos and they seem like a ton of videos, but they are probably like 4-minute videos on that stuff, but they're really, really informational videos on your blood cells, and they're really good. So, you know, taking notes on that stuff is really important, and she does a really good job with it. So parasitology things, you know, just reviewing that stuff, and like I said, putting that stuff in your notebook and then reviewing the life cycle of it is important. You don't have to put a ton of stuff in it, just like the really basic things of like, what's the intermediate host, what does that all mean? So I'll put that stuff up to you as well, so that you guys are good on that. So I would love that in my book. So yeah, exactly. Having that stuff in your book and then just being able to know that stuff, because of course, what if an owner asks about these things too? You can easily just grab it and then be able to know that stuff so you can explain it to the owner, because the nice thing is that you guys are the ones who explain this stuff to owners in owner terms, right? Sometimes you have doctors who have a harder time explaining it to owners because they talk very much in medical terminology. So you relate a lot better to owners at times. So when you can write things down in terms where like you can in your book, you know, draw stuff out and draw it out in like the intermediate host and how that works. As you write it right now, as you're learning it, then later on when you're in practice, you then can draw it out again for an owner and explain it that way. So it's really good to be able to do that now and then teach it to an owner later on. So you really grasp those concepts. I'm glad you really like those videos. That's awesome. Yes, I will send you more parasitology stuff. Absolutely. Yeah, my parasitology stuff, it's a bit lacking because I actually, I used to have a bunch of it. And then long story short, I thought I wasn't going to teach again. So I actually got rid of it. And so now I have to kind of recreate the wheel. So I will send you more stuff. When he asked me the drip rate last week, and I was like, I don't have my book. Thank you, Meryl, for helping me. Yeah, Meryl's been really helpful. So awesome job, Meryl, for being my little math tutor. I love it. Great.
Do you have any suggestions for I don't know where to go with this, but where to look for brush up on radiology? Because I'm not going to be able to do that part with you guys, as I will be taking this exam.
Yeah. Let me send you, I'll send you my stuff for the radiology stuff before you get ready. But there's stuff that you can do, especially on IDEX, that's really good that I usually put in for our stuff. Because they have like IDEX like learning aspects. Are you in a clinic right now?
Yes.
And then do you guys have IDEX equipment and all of that?
We do.
Oh, okay, perfect.
The only problem is they don't really have time to teach because it's an emergency clinic.
Yeah.
And lately, everything that we get is truly a critical case.
Yeah.
And they don't have time. Okay, we're doing this because.
Right.
They don't have time for that.
So, and I only ask because IDEX is like really weird about how you do their IDEX learning stuff. So, I'll talk to you about how we can get onto the IDEX learning platform. So, I'll send you the information, but they have like a ton of IDEX learning things. And then there's, like some CE on there that goes over like positioning and all of that. And then I'll send you all the information for radiology so that you can look at that stuff early. So
yeah, if you have time to do that, that would be really, really helpful.
Absolutely. Absolutely.
Thank you.
Yeah. Any other questions?
I have a question as far as like parasitology. I've noticed like I really like your little diagrams, but one thing that that wasn't clicking for me is as term as like putting it in like my review book. Like I didn't know how to structure it because like you said, we don't need to know everything, but how do you nitpick what are the important things and what are the things that like you don't necessarily need to know by heart?
Right. So think when you're thinking of parasitology, the things that are really important are, you know, how the parasites, of course, like what are they? What are their names? Their scientific, obviously their names, their common names, right? And then what do they cause, right? Like what disease process do they cause, to what animal? Their host and their intermediate host, right? And then by Kim, and then their life cycle, right? So even if you draw out like saying their life cycle, and I usually like will say, okay, here's your parasite per se, right? And then drawing out like how they grow essentially. I'm just drawing whatever. And then here they hit the intermediate host, whatever it is. And then they do this with the intermediate host. And then finally they go to the host itself. And then they are put out into the environment. All right. And then they start over again. So as long as you have kind of that life cycle, and then talking about also like what's the treatment, so as knowing like what do you commonly use for treatment as well. So I mean, not necessarily knowing like you don't have to know everything about it, but just the main things of what what is caused by it, you know. I mean, there's certain parasites that can do some pretty crazy damage, so I mean it's good to know. And I mean, there are a lot of parasites, like there are like 300 bazillion parasites. So you don't have to know all of those, but the pretty common ones that we see. So.
Okay. So I find like I overcomplicate things in my head and I'm like, great, how am I to explain this to an owner? I have no idea.
Yeah. Yeah.
Okay.
And I think I posted some pictures on our Facebook page of what some of my students have done in the past of like how they wrote their parasitology stuff. Okay. So you might want to look in there. If I ever find Giardia, I'm retiring. If you ever find it or if you ever get it.
I had a case of it on an internship.
Yeah, I mean, you should find Giardia all the time. Like we see Giardia all the time. So yeah, I mean, it's hard to see for sure, but yeah, I mean, there's Giardia everywhere. Yeah, but you never see them, and yeah, it's hard to see in house. It's missed a lot. Like there's Giardia everywhere. So yeah, my students, I should say, we saw a lot of cases. Like our school took in a lot of animals that were from like the shelter and stuff like that, and pretty much every week we would have Giardia cases, so they got good at finding Giardia. Two people actually got tattoos of Giardia on their bodies, which there was like, okay.
I mean, it is a cool little thing.
It is cute, but yeah, want to live with Giardia forever, right? you know you're from the vet tech field when you have Giardia. Still work in a flea and tick research, and we use dogs that came from shelters and found it. Gross. Yeah, gross.
Oh, I have a question on that.
Yeah.
So as far as like flea and tick stuff, well, we're in mid-season of that, and a lot of owners, they'll just like, oh, I don't go to the vet, like I just bought this stuff at the pet store or like whatever. And oftentimes it's really toxic stuff that will actually kill pets. How do you get through the pet owner of like, yeah, even though it's cheaper at the pet store, like you're gambling with your pet's life? Like, it's just frustrating.
It's a work in progress. You know, it's been a work in progress. So,
like, are those things actually like tested before they're put out on the market? Like what makes the difference between the stuff that is in veterinary medicine and that are allowed to be on the stores?
I don't you know, it's just a matter of yeah, efficacy, I guess, and you know, just it's not well regulated as well. So you know, there's some that have had major complications, and you know, it's about client education. So you know, it's just kind of one of our jobs is to continue educating owners and saying that, you know, these things are not well regulated. They come, you know, same thing with like things from, you know, Chewy and stuff too. They could come from distribution centers that are not well, like in temperature regulated places. So we don't know if they are, you know, able to work properly. So we know where like our medications come from and stuff like that. So we do recommend getting medications and stuff like that from the veterinarian office, and just hoping that owners continue to get their medications and stuff from veterinary offices. So it's just a continued process to try to get people to get their stuff from us. So yeah, I mean, and there's a lot of you know, fake products out there too. Like you can, and it's not just veterinary medicine stuff. Like it comes from all different things, you know, hair products, like human hair products that you can buy. They're fake. They just, you know, slap a label on and say that it's that, and it's not. So you just, yeah, everyone has to be careful of what you buy and just buy it from a well-known source. So
like how would a person like differentiate, oh, I bought this shampoo and it says it'll guarantee to kill flea and ticks, like and then you have cases where the animal actually dies, or they'll do that with like a flea and tick collar and like the animal ends up dying.
Yeah, well, wait till we talk about nutrition. You know, like there is no guarantee. There is not well regulated of anything, and unfortunately, the testing is done on our pets. So and then unfortunately, people just don't know that, you know. So it is, we are the people that have to how do I say it? We are the people that have to just educate as best we can to owners and recommend products that we know are good products that are tested and we know that work and are safe for pet owners. So
the other thing that I noticed too is that even like in vet medicine, we have products that they're kind of iffy, I want to say. Like I have, let's say, Brevecto. A lot of people are like, oh no, I don't want Brevecto because it causes seizures, but it doesn't cause seizures in every single dog. So
yeah,
like,
so
how do you choose what's the right thing for which animal, basically?
Yeah, so Jamie just said the Seresto collar. So yeah, the Seresto collar too. And I've read that too, Jamie, with the Seresto collar. And from what my understanding is, and when I've talked to other veterinarians too, a lot of the Seresto collars, and this is kind of where it came in with getting it from outside sources. It was that People had been getting them from outside sources where a lot of them were not truly Seresto collars themselves, and that they were coming from potentially fake Seresto collars. And so making sure that we're getting that from a reliable source, and that that veterinarians are still recommending Seresto collars as long as they come from that reliable source. Because again, I have used them and been perfectly fine. So I think being cautious, yes. But yeah, I've not had an issue, of course. With your question, yeah, I agree. With every patient, you have to be cautious, and not every animal it fits every box, right? So like, depending on other things that's going on with a patient, they have to choose what's best for that patient. So if it's going to cause a seizure or something to that effect, they have to be cautious. So whether it's an MDR1 mutation type of thing that they might not be able to get, then that's fine, if that's the case. But that product doesn't necessarily mean that all patients are going to get a seizure per se. So
Yes.
yeah. Great. Bye, Amanda. Thank you for hanging out. Have a great day. Bye, Andy. Take care. Any other questions?